Hey everybody, I hope you guys are doing well. Exciting day for us. We get to start a new chapter and we get to talk about something called correlation. And correlation is a word that we have to be careful about. And I believe I've reminded you a couple times maybe throughout the year where people have wanted to use the word correlation in a situation that is not appropriate. So what is correlation? What is that about? Well, correlation shows the relationship between two different variables. You have to have two variables. And when students in here have used it in the past, they've only been talking about one variable, and you can't have correlation with one. It has to be two variables. One is the independent variable, which we usually call x, and the other is the dependent variable, which we usually call y. Now, a couple other terms that you'll hear sometimes for the independent and dependent variable when we talk about correlation is the explanatory variable and the response variable. So we have the independent, the kind of input, and we have the kind of like the output, right, for our variables. Well, it's the explanatory and the response, because we're looking to see, is there a relationship between the two? Does the independent variable kind of explain what's happening with the dependent, with the response variable? So I have an example here that has to deal with the number of chirps heard by crickets at different temperatures. So we can see in the table here, there were 44 chirps when the temperature was 60.5. There we go. That might help me a little bit. There we go. No, 80.5. Okay, so 44 chirps when it was 80.5 degrees. There's 35 chirps when it's 70.5 degrees. 20.4 chirps when there was 57. How can there be 0.4 chirps? I didn't give you a lot of information from this study, but they would have been averaging the number of chirps to get a number like 20.4 and so on. So let's graph these data points and let's determine if there is a relationship between the two variables. Do we see any trends going on? So what we're going to do is we're going to grab our TI-84s. I'll do mine on the computer screen for you. You can use your computer calculator or your handheld calculator if you'd like. There are other options. GeoGebra can do some great things when it comes to finding correlations, and but I'm just going to stick to the TI-84 to try to keep it simple for you and just give you one way to do that. So what I need to do is grab my calculator. Here it is. And I'm going to go into stat. I'm going to choose edit. And I need to put my data into list 1 and list 2. List 1 will be my x's, my independent, my explanatory variable, and my list 2 will be my y values, which would be my dependent variable or the response variable. Now, I had a decision to make here when looking at this information here. Do I believe that one of these is the explanatory and one is the response? And if I'm looking for a relationship between the two, I have to pick. And I can't help but think here that it's probably the temperature that's explaining the number of chirps more than the chirps explaining the temperature. Now, we could do some exploration on what happens if you switch it, and that's just fine. Don't get overly concerned. But if you are leaning towards one being explaining the other, then go with that. So that's what I did here. I chose to put the temperature into list 1. Let's see here, where's my calculator? Seem to have lost it. There it is. Okay. I put, well, now I lost it again. I put my temperature into list 1, and I put my number of chirps into list 2. And now what we'll do is we'll graph these and we'll make a scatter plot. So to make my scatter plot, I'm going to go to, first off, I'm going to go to y equals. I'm going to make sure there isn't anything in there. So I'm going to clear out any of that. I'm then going to go to stat plot. So second, stat plot. I'm going to choose plot 1. I'm going to turn it on. I want the type to be a scatter plot, which is the first one. My x's are in list 1. My y's are in list 2. So I guess technically we could have put them in the other order and then just done it here, but I just like to keep it simpler. I always like the x's in 1 and the y's in list 2. Mark, you can choose how you want your points marked. I'm a kind of a fan of the square here and color, so on. So that looks good. if you quit out of that and just go to y equals, one thing I want you to notice is now this plot 1 is highlighted, so we can see that it is turned on. It's good to go. Before I hit graph, I should consider my window. Now, when we look at our x's, which are the temperatures, it looks like our smallest temperature is 52 degrees. Our greatest temperature is 80.5 degrees. So let's kind of go in that maybe 40 to 90 for the x's. And let's go by tens. All right, y's, number of chirps. Fewest chirps, 18.5. Most chirps, 44. Let's just go 0 to 50. How about that? Let's go by tens there as well. All right, hit graph. And this is what we see. So the question that I asked was, does there appear to be a relationship between these two variables? There we go. So remember that the x-axis is the temperature and the y-axis is the number of chirps. And I think that there does look to be a relationship. It looks like as the temperature goes up, the number of chirps goes up as well. So there is a relationship, but how do we measure that relationship? How do we describe how good of a relationship it is? Well, we use something called a correlation coefficient. So here's some information about our correlation coefficient R. I hope this is familiar to you to some extent. The closer the absolute value of R is, okay, R could be positive or negative, the closer the absolute value of R is to 1, the better the data fits the line. If R is a 1, it means our scatter plot forms a perfect positive sloping line. Okay? It's completely linear with a positive slope. If R equals 0, there is no correlation whatsoever. There's no relationship between the x's and the y's, what we think are the explanatory and the response variables. If R is a negative 1, it is also a perfect line, but now its slope is negative. Now, it doesn't mean the slope is negative 1. Don't make that confusion. I know sometimes students try to think that R is 1 is a perfect line with a slope line. No. If R is 1, it could look like that. It could look like that. It could even look just barely a positive slope like this. Those would all have points on them that made those lines and they have a positive slope. R equals negative 1 is a perfect line with a negative slope. Doesn't mean the slope's negative 1, just means the slope is negative. Okay? To help you understand this, I got a little bit of more information here about R, and then we'll look at some more examples of scatter plots with their correlation coefficients. One thing we need to know is R is unitless. That means there's no units applied to it. If we look back at this situation, it's not like R is chirps per temperature or something like that. Again, it's not a slope. There are no units. Now, I'm not going to give you guys the formula for calculating R, but the units would cancel out in that. We're going to just use technology to calculate R. It goes from negative 1 to 1. So there's that range. Okay, R has to be less than or equal to 1, greater than or equal to negative 1, less than or equal to 1. 0 means there's no linear correlation at all. I kind of stated some of this, but if R is positive, remember we said that means it's trending upward. That means as X increases, Y tends to increase. And when we look at this graph, that's what I notice here. As the X increases, the Y's increase. So I think that this one is going to have a positive correlation. Because as X increases, Y increases. Okay. Negative values means that as X increases, Y decreases. Even if it's not in a perfect line, okay, as long as it's negative. So like if R equals negative 0.6, it's going to tend to trend down. Okay. The value of R does not change when units are converted. That's another interesting thing with this, is that the R value doesn't change when we change the unit. So for example, like if I change my temperature, if this was in degrees Fahrenheit and I converted it to degrees Celsius, The graph might look a little bit different because the points are going to be in slightly different places, but the R value does not change. Same if this is like chirps per minute and I change it to chirps per hour, you know, that's going to change those Y values, but it wouldn't change the value of R. So we have some flexibility then with our units. All right, so let's look at some examples of R values. Okay, this first example here in the top left has an R value of equal to 1. Notice it is making a perfect positive sloping line. Now again, it could also be this. It doesn't mean the slope is exactly 1. As long as it's positive and makes a perfect line, the R value is 1. Okay. Over here on the left, we have an R value of -1, and then I kind of gave a little in between here. Look at an R value of 0. Notice it's just random point. It's not trending one way or the other. There is no correlation. Here is point A. It's definitely trending upward. Okay, definitely not a perfect line, but certainly trending upward, easier to see that trend. Here is R equal to 0.4. I think, again, this is trending upward slightly, but not as strongly correlated as the 0.8. And then here would be -0.4, and here would be -0.8. Okay, let's look at some more examples. This is highlighting again the fact that R equals 1 does not imply a particular slope. All three of these would have an R value equal to +1. All three of these would have an R value equal to -1. How about a horizontal line? Well, that we wouldn't have an R value for that. We can't say there's no correlation. We can't say it has a positive slope or a negative slope. So no R value for that one. There we go. Here are all examples of a correlation coefficient equal to 0. Is there a relationship? And when I look at this one, I'm down here. When I look at this one, is there a relationship between X's and Y's? Absolutely. It looks like it follows a pattern, doesn't it? However, the correlation is 0 because our correlation coefficient R measures a linear relationship. There is no linear relationship there. Same with this one. This looks like it might be parabola kind of shaped, maybe a quadratic of some sort. However, R calculates linear correlation, so that's 0. All of these have a correlation of 0, even though that there are some trends that we can see in the data. Okay? So, one thing that we need to do here is, hold on a second, where am I at? I forgot to put the problem in here. Oh well. Let's calculate right now the correlation coefficient for our chirps and temperature. Not chips. I like chips. Maybe I'll have some chips with lunch today, but chirps. Okay, so here's how we're going to do this on our calculator. We have our scatter plot in. Okay. We are going to quit out of this. We're going to go stat. We are going to go over to calculate. We're going to choose a linear regression. Okay, and the reason I remember that again is correlation coefficients show a linear relationship. And I'm going to hit enter. Our X's are in list 1. Our Y's are in list 2. There's no frequency list. We don't have to store that regression equation right now. We're going to talk about that in another lesson. Let's hit enter. And notice it gives me the equation of a line. However, my calculator should give me the correlation coefficient. What I have to do is I have to turn that on. And maybe your calculator already has it on and it showed you a value for R. Here's how we're going to have to do it. We're going to go to the catalog, which is down here in the 0 in blue. So we go second catalog, and we have to find diagnostics. Okay, and we have to turn that on. So I'm going to scroll here a bit till I get to the D's. Get in there. I think you can also do an alpha and then like type in a D and it'll jump there, but we're getting close. And we want to choose this one, diagnostic on. So I hit enter and then I go enter and now it's on. So now if I go back to the previous one where I chose that linear regression, now it gives me an R value. Time's up on this video. I'm going to wrap it up in the next video that's going to come.